So today we're starting Unit 3. We are going to be working in Lesson 1C, but before we do, let's go ahead and fill in our table of contents in our interactive notebook. Pages 37 and 38 should be Unit C vocabulary. So we really only have a couple of words to write down, but let's go ahead and fill those in on page 37. So if you turn to page 37, remember we want this little tab hanging off the side that says C for Unit C so that we can open right up to Unit C vocabulary. And right here on page 37 is where we're going to start. So the first word is system of equations. So this whole unit is about systems of equations. A system is a set of two or more equations that occur at the same time. So they're also known as simultaneous equations. They're equations that happen at the same time. And so we group them together usually with this little curly bracket. But if you can't draw the curly bracket, sometimes you could also draw a straight edge bracket. But that would group the equations together. So that's what you're going to see in this unit. So how would we solve two equations that are happening at the same time? Well, the solution to a system is the one and only point that would make all the equations true. Now, I put on here all equations, but really, most of the time it's going to be two equations. So it's the one and only point, that both equations would share. And so on a graph, we would see the one and only point that happens on both is going to happen at this cross point right here. And so this is the solution to a system. And so when we're graphing, well, all we need to do is look for the cross point. Okay, so that's what we're going to be finding in this entire unit. There's a lot of different ways to find it. We could graph, we could solve algebraically a couple different ways, but that's what we're trying to find. So X marks the spot. We're looking for the cross point on a graph. So it's going to make it very easy, and remember, you can always go back and pause this video if you need to go back and see those vocabulary words, because now I'm going to switch over to Lesson 1C. So it becomes very easy if we see a graph to find our solution. But how do we make sure that that solution is the true solution to the system? Well, right here, we're going to look at the given point and see if this truly is the answer to this system. Remember, to be the one and only answer, it has to work for both equations. And so for the first equation, I'm going to plug in 4 for x and 2 for y because I have both variables. And so this equation would become 2 equals -4 because I'm plugging in 2 for y and 4 for x plus 2. Now I just solve. That means 2 should equal, well, -4 plus 2 is -2. So does that work out? Is 2 equal to -2? No. So since this one does not work for this equation, this answer is going to be a no. That is not the answer to this system. And I made that look like an X, but let's just put a sad face in front of that equation. If it doesn't work for one, it's not going to work for either. And so that would not be a solution to that system. Let's try number 2. Number 2 gives us the point 1, 2. So that's where x is 1 and y is 2. So instead of y, I'm going to write 2 equals, instead of x, I'm going to write 1, and then I'll copy the rest of the equation, plus 1. 2 equals 1 plus 1. Well, I'm going to bring down the 2, and then I'm going to work out this side. 1 plus 1 is 2, and because I know 2 is equal to 2, that tells me that that works for the first equation. But that doesn't mean it's a solution to the entire system. We have to check both. So to the side right here, please write check both. It has to work for both. Okay, so let's plug it into the next one. 2 times x. So that means I'm going to write 2 times 1 plus y. So instead of y, I'm going to write 2 should equal 4. Let's check and see if that's true. 2 times 1 is 2. Bring down the plus 2, bring down the equals 4. And 2 plus 2 is 4. Now check, does 4 equal 4? Yes. So because that one point worked in both of those equations, this answer would be yes. That is a solution to the system. Let's try again. Number 3. In this case, x is -3, y is 2. So that means this would say -3 plus 2 equals -1. -3 plus 2 is -1. And because -1 is equal to -1, it works for the first equation. Now let's try the second. Instead of y, I'll plug in 2. Plus 3 times the x, so the x is -3, equals 4. So that would say 2 plus -9 equals 4, which would give me -7 equals 4. Is that true? No. Since that does not work for the second equation, this is not a solution to the system. It has to work for both. All right, number 4. Let's see if this one is. There should be a comma there. So in this case, x is 4, y is -1. So for the first equation, we would have -1 equals 2 times 4 minus 9. That gives us -8. -1 would equal 8 minus 9. So that means -1 should equal, well, 8 take away 9 is -1. Those do come out equal, so we know it works for the first equation. But let's check the second. On the second equation, we have x minus y. So that means we would have 4 minus, and y is -1. 4 minus -1 equals 5. If you remember back in 7th grade, minus and negative means add the opposite. So that really says 4 plus 1, which is 5. And because 5 equals 5, that worked for the second equation. Because that point works for both equations, that is a solution to the system. Yes. All right, so how did they get these points? Well, one way to get those points is by graphing. And so here we see 2 lines that have already been graphed. It says, place a point on the solution to indicate the solution to the system and write it down. Assume there are 2 lines on each graph. All right, so all we have to do is find the answer. Remember what we said in our vocabulary, X marks the spot. The one and only answer that works for both of these equations is this point right there. It's the cross point. It's where they meet. So for this system, the solution would be -4, -1 would be the solution to this system. Let's try this one. X marks the spot. There it is. So this solution would be 2, -1 as the solution to this system. But what about this one? If we're looking for the point where these lines cross, what happens here? So will these lines ever cross? Well, let's look. This one looks like it's angled that way. This one looks like it's angled the same way. What do we know about lines that are angled the same way? Well, those are called parallel. So this one will have no solution because they never cross. No solution. We can write, I won't use parentheses, but we can write parallel lines. Well, how could we prove that they're parallel? Well, they're parallel if they're changing by the same amount. They're angled the same way. How do we calculate the change? Well, back in the last unit, we knew it was change in y over change in x. So let's find 2 good points. There's a good point. There's a good point. The slope of this line is up 1, 2, 3, 4, up 4 over 1, 2, 3, 4, 5, up 4 over 5. So the slope of this line is 4 over 5. What about this one? It crosses here, and another good point is here. So this one goes up 1, 2, 3, 4 over 1, 2, 3, 4, 5. This one also has a slope of 4/5, up 4 over 5. So that can prove that they're parallel because they're angled the same way. What these equations would look like is y equals 4/5 x. Now for the top one, it crosses at 0, so I'll just put plus 0. For the second equation, it would be y equals 4/5 x minus 4. So if we had equations, that's what they would look like if they're parallel. And if they're parallel, they'll never cross, so there's no solution. Well, what about this one? It said assume each graph has 2 lines. So if there are 2 lines here, and I'm looking for the point where the lines meet, how many points do these lines meet at? Well, it looks like they're meeting at every single point they have. And so how would I list every single point on the line? That would be an infinite amount of points. So that would be infinitely many solutions. Does that sound familiar? It should. It's going to come back up. If we did this before. We had seen this with variables on both sides, and that will show up again. So if they're the same line, there's infinitely many solutions because they're overlapping an infinite amount of points. All right, on to the back. Now what do we do? So it says, what is the solution for each system? So I see that these lines are angled differently, so I know they'll cross. We just have to find that cross point. Well, they weren't finished, and so what we can do is find the slope and continue it. That's what we do here. So this one, it looks like it went up 1, 2, 3 over 1. 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 So that looks like it's enough space now that it should show where they're meeting up. So I can see that one would continue like that. Now for this one, there's a good cross point, there's a good cross point. Let's check another. This one looks like it's going, let's see, this one's going, oh, there's a lot of good cross points. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, this one I noticed when I plot that point, it matches one on the other line. And so that one's going to be our solution. I'll go ahead and continue this line, but I can now see that point. So that point would be 2, 5. So the solution to this system is 2, 5. If we had the equations, we could figure them out, but if we had them, we could plug that in to check. All right, what about this one? Let's go ahead and do that again. This one looks like it's going down 1 over 2, down 1 over 2. So I'll continue. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. That looks like it's enough points to meet up with the other line eventually. So let's go ahead and continue this one. And now the last one. Let's see, this one looks like it's going from here to here to here, so that's going up 1 over 3, up 1 over 3, up 1, oh, over 3, found a point, up 1 over 3. So we found the point where they meet up. I circled it. I think that's best to do. On the computer, obviously, you won't be able to circle it, but I think on paper it helps. So this point is 3, 2. So the solution to this system is 3, 2. Now let's draw our own lines. Draw a line to the existing graph that will create infinitely many solutions. Well, that's easy. It's the same line. So I'll just put in, oops, don't do that on your line. I'll just put in arrows to show it's the same line. Okay, what about this one? Draw a line to the existing graph to create no solutions. So these need to be parallel because remember, no solution means never ever crossing. So I just need the slope. Down 1, 2 over 1. Down 2 over 1. All right, so I need to pick another point. So I'll pick one that's away from this y-intercept, and then I'll go down 2 over 1, down 2 over 1, or up 2 left 1, up 2 left 1. All right, so I picked one that was really, really close, but I made sure that it had the same slope. Okay, so I'm going to write that in, same slope. All right, last ones. Let's make our own lines that have a solution of 0, 2. So I'm going to plot the point, and then I could draw any line that I want. So I'll just make this one go up. It'll make the other one go down. When you get to draw your own lines, you can make them do whatever you want, as long as they're crossing at the point that's given. All right, so you're going to try this on My Open Math. Let me know if you have questions.